All right, so this video is going to go over pages 11 through 13. So we're going to start talking about power in this one. So power is the rate of doing work. Okay, so basically how quick can you get the work done? To find the rate of doing any quantity, how fast, you take the quantity and divide it by time. Okay, therefore power is the amount of work divided by time. Okay, so the quicker you can do it, the more power you have. Okay, so our equation is power equals work over time. So we're going to abbreviate that, so W over T. Now, work also equals force times distance, so you could also say power equals force times distance over time. Okay, if it's lifting something, so now force is M times G, so I like to say this is the lift one. So if you want to figure out how much power is being done while lifting something, now that's mass times gravity times distance over time. Okay, and then lastly, if you noticed, D over T is the same thing as velocity. So displacement over time is velocity. So you could say power is also force times velocity. So if they give you a force and they give you a velocity, then you can use that one as well. So it's kind of just using those equations and intertwining them. Okay, so just gotta make sure you gotta realize what you have. Okay, so that's why it helps to label things out so you can figure out which equation you use. Horsepower is a non-SI unit of power. So again, non-SI means non-standard international. So not everybody uses horsepower. Okay, but we use it quite a bit, especially when you're talking about engines, things like that. Okay, so 1 horsepower equals 746 watts. Okay, so your units for power, okay, can be watts. It can be horsepower. Okay, or it can actually be joules per second. Okay, which is work is in joules, time is in seconds, so joules divided by seconds. Great, so an example, if a 10 kilogram box is lifted, so there's a key word there, lifted. Okay, so that means gravity is going to matter, so mass is going to matter. So mass, oops, let me fix that. So mass is 10 kilograms. Okay, lifted up 2 meters. Okay, so my distance is 2 meters. How much power is exerted in watts, kilowatts, and horsepower? Okay, if it was lifted up in A, the version A, so time A would be 2 seconds. Okay, time B will do 30 seconds. So we'll just do version A first. Okay, so I'm looking for power. Okay, so P is our question mark. Okay, so I'm going to figure out work first because power is work divided by time. I have time. I've got 2 seconds, but I don't even have work. Okay, so we're going to figure out what work is first. So remember, I'm lifting. So work is force times distance over time. But since we're lifting, force is now mass times gravity times distance over time. Okay, so now could you find the force first, mass times gravity? That's fine. You can do that first and then plug it in. Whatever you want to do. I just like doing it all in one thing. Okay, anytime we're lifting, I know it's always this equation right here for power. Okay, so my mass would be 10 kilograms. Gravity would be 9.8. And my distance would be 2 meters. My time is going to be 2 seconds. Okay, so that comes out to be 98 watts. So that is how much power is being done over that certain amount of time. Now, 98 watts, that marks off one of the answers because it wanted watts, but I also want kilowatts and horsepower. So let's fix those. So remember, 1 kilo of anything equals 1,000 base units. So 1 kilowatt equals 1,000 watts. So if I have 98 watts, now I figure out how many kilowatts that is. Okay, so kilo is the big one, and watts is the small one. So we're going to take that 98 and divide it by 1,000. Okay, which give me 0.098 kilowatts. Okay, so if you're ever confused on whether to multiply or divide, you got to look at what are you in? Is watts bigger or is kilowatts bigger? So if kilowatts bigger, okay, it would not make sense to multiply by 1,000 because then all of a sudden you went from 98 watts to 98,000 kilowatts. So if kilowatts is bigger and all of a sudden now you have 98,000 kilowatts, that means you are slightly off a little bit. Okay, so if watts is smaller, okay, that means whenever you get to kilowatts, you should have a smaller answer because it's a bigger unit. So I've got kilowatts, I've got watts. Now I'm going to get to horsepower. So remember, 1 horsepower equals 746 watts. So if I've got 98 watts, so I'm going to take that 98 and divide it by 746. So that means I've got a little whopping 0.13 horsepower. So again, it's not like your big engines. Okay, you do not always need to have a ton of horsepower, because I think that's the power of 1 horse. That's quite a bit. Okay, and you're just talking about lifting a 10 kilogram box up 2 meters. So it should not take a ton of horsepower there. Okay, so that was for 2 seconds. Okay, so we're going to do the same thing now for part B, which is 30 seconds. So we're going to do the same thing. Work equals mass, so 10 times gravity, which is 9.8, times distance, which is 2. That's all the same. But now my time is 30 seconds. Okay, so now you're dividing by a bigger number, which means my watts is actually going to get smaller. Which should make sense, because if power is the amount of work done over a certain amount of time, if it takes you 30 seconds to get it done, that's not very much power, versus something that you can get done in 2 seconds. That requires a lot more power. Okay, so that is my first answer, is 6.5 watts. I want to know how many kilowatts that is. So 6.5 divided by 1,000. Okay, and I get a small 0.0065 kilowatts. Okay, then I'm going to go into horsepower. So I'm going to take that 6.5 again and divide it by my 746. And we've got a whopping 0.009 horsepower. So again, remember, the more power you have means you get the work done quicker. Okay. So moving on to the next page. So this is actually a good page for doing mixed practice. So it says how much work is being done pulling a wagon 50 meters along a level road by a force of 20 newtons applied to the handle if the handle makes a 30-degree angle with the ground. Okay, so I was given a mass. I'm sorry, I actually wasn't given a mass. Okay, I was given a distance, 50 meters. I was given a force, and I was given an angle. So this is just a work problem. We're not even asking about power in this problem. So remember, work equals force times cosine of your angle times distance. Okay, so my force would be 20 newtons. Cosine of 30 times a distance of 50. So multiply all those out, and I get 866 joules of work. Okay, so number 2, a boy's mass is 50 kilograms. If he walks up a flight of stairs 12 meters high, so he is walking up. Okay, when you're going upstairs, okay, gravity is going against you. It is pulling you down. So mass does matter in this case. So he walked up flight of stairs 12 meters high in 30 seconds. What power has he used? So we're talking about going up. So now power equals work divided by time. Like, I'm going to go ahead and plug in my work. So work equals mass times gravity times distance, since we're going up, over time. Okay, so mass would be 50. Gravity would be 9.8. Distance would be 12. And my time is 30 seconds. Okay, so divide all that out, and you get 196 watts. 3, an elevator. So elevator, that means we are going up and down. So gravity does matter here. Okay, in the Empire State Building in New York, rises to the 80th floor in 50 seconds. So I gave you time. If the height is 302 meters, so I gave you distance. What power, so that means you're looking for P, must be developed in order to lift 12 people averaging 80 kilograms each to this floor. Okay, so I'm going to label out what I have. Okay, so distance is 302 meters. Okay, time is 50 seconds. Okay, my mass, I have 12 people averaging 80 kilograms. So I'm going to do 12 times 80. So that means I have a total mass of 960 kilograms. Now, I like to label stuff like this because sometimes if you get to a problem and you're just starting to read numbers and your mind kind of goes into shutdown mode, start off just by labeling things. That's like baby steps. And then once you kind of figure out what you have, then you can start picking equations that have those same letters. And you never know, you might get something right if you're totally stranded. Okay, that might actually help you pinpoint at least where you can go. So I'm looking for power. Okay, so I'm going up. Okay, so remember what we did. So power is work divided by time, but since we're going up, power equals mass times gravity times distance over time. Okay, so my mass would be 960. Gravity is 9.8. Distance is 302 meters. And time, okay, it took 50 seconds. So do all that math and you get 56,824 watts. It is okay to get big numbers. Okay, you got to think about is in order for that elevator to raise up that much weight, okay, that many floors or that distance, it takes quite a bit of power, okay, to be able to get that done. Okay, 4, a 2 kilogram mass is raised. Okay, so raised. So that means so gravity matters. So mass is 2 kilograms at a speed of 3 meters per second. Okay, so I'm just going to say velocity equals 3 meters per second. We'll see if we need to use it or not. By a vertical rope. What is the power supplied by the rope? So P would be my question mark. Okay, so remember we talked about power can also equal force times velocity. Okay, I know a velocity. My force is, since I'm lifting something, remember force equals mass times gravity times velocity. So we can actually take that mass, which is 2, okay, times gravity, which is 9.8, and multiply it by my velocity of 3 meters per second. That'll come out to be 58.8 watts. Okay, so we're just kind of showing you all the different power equations you can use. Okay, so again, this is why it helps to label things so you can figure out what you can use. So number 5, a 70 kilogram person runs up a long flight of stairs in 4 seconds. So I'm going up, so mass does matter. Okay, in 4 seconds, so time is 4 seconds. The vertical height of the stairs is 4.5 meters, so distance is 4.5 meters. Calculate the power, so power is your question mark, in watts and horsepower. So remember we're going up, so power equals mass times gravity times distance over time. Okay, so 70 kilograms is your mass, gravity is 9.8. Okay, your distance is 4.5 meters, and your time is 4 seconds. So that comes out to be 772 watts. Now there's your first answer. We want it in horsepower too. So I'm going to take that 772 and divide it by 746. That comes out to be 1.03 horsepower. How long will it take a 2 horsepower motor? Okay, so I gave you power, but it's in horsepower. So we cannot use horsepower because your equation has to be in watts. Okay, so if you want to fix that, take that 2 horsepower and multiply it by 746 because that's how many watts are in 1 horsepower. Okay, which would be 1,492 watts. Okay, sorry, my 14 kind of looks rough there. So 1,492 watts. Okay, so you cannot use horsepower. You have to be in watts. Okay, watts only. Now, I'm lifting, so mass does matter. So mass is going to be 400 kilograms. So that means gravity matters. To the 6-story window, 20 meters above. Okay, so my distance is 20 meters. So I'm looking for time. I want to know how long it will take. So T is your question mark. So remember we're lifting. So remember power equals mass times gravity times distance over time. So power is now 1,492. Okay, your mass is 400. Gravity is 9.8. Distance is 20. Time you don't know. Now, please be careful with this. This is probably one of the number one math mistakes we see is I see people try to multiply both sides by whatever 400 times 9.8 times 20 is. Okay, if that was on bottom, then you could do that. Okay, if you have a variable on bottom, here's your shortcut. Just switch those two. So take that 400 times 9.8 times 20 and divide it by 1,492, which would come out to be 52.5 seconds. Because in this case, if you actually did multiply those, you're going to get a huge number. So 400 times 9.8 times 20 times 1492, that is a ton of seconds. Okay, so that would kind of be a hint that you were a little off. If you're getting like in the millions or high 100,000 stuff in seconds, that's probably a little off because that's a lot of time. So again, if you have a variable on bottom, you can switch those two. That's like a little shortcut. So just kind of keep that in your mind. So let's move on to number 7. So 7 says a hydraulic jack provides a lifting force of 800 newtons. Now, I already gave you force right here. Okay, I didn't give you mass because remember, force is mass times gravity. In this case, I just skipped this part and just told you what force was. So you don't have to have a mass if I told you what the actual upward force would be. This basically is mass times gravity. I just gave it to you already. At a speed of 0.5 meters per second. So there's your velocity. So what power does it produce? So remember, power can also equal force times velocity. So I'm going to take that 800 and just multiply it by my velocity of 0.5. That comes out to be 400 watts. So again, not every problem has to be super intricate. Okay, so don't think everything takes a whole page of work to be done. Okay, trick is just labeling what you have and then figuring out which equation to use. Number 8, if a car generates 15 horsepower when traveling at a steady 80 kilometers per hour, what must the average force exerted on the car due to all frictional forces? Okay, so again, I've got power, but I gave it to you in horsepower, so that does me no good. Okay, so 15 times 746. That gives me 11,190 watts. So I need watts. So I fixed that, so that one's good. And then they gave you velocity in kilometers per hour. So remember, if you want to go from kilometers per hour to meters per second, take that 80 and divide it by 3.6, and that gives you 22.2 meters per second. Now, if you ever want to know which should you do, should you multiply by 3.6 or divide by 3.6? The way I remember this is if I'm going from hours to a second, okay, my number should get smaller. Okay, I should not be able to cover more ground in less amount of time. So if I'm going from hours to seconds, you've got to divide because you want a smaller number because you're going to have a shorter amount of time. Now, I've got velocity now. I've got my power. So remember, power equals force times velocity. Okay, I'm looking for F. That's your question mark. So power is 11,190 equals force. I don't know. I'm going to leave it as F. And my velocity is now 22.2 meters per second. So divide both sides by 22.2, and you get a force of 504 newtons. And there's your answer. Okay, 9. Calculate the work that gravity does on the object as it slides down to the ground. Okay, all I care about is where it is here and where it is here. Okay, it does not matter that it's doing this whole path right here. Okay, I want to know how much work gravity is doing to bring it from this height down to this height. Okay, so I do not care about horizontal distance at all. Okay, there's a lot of things in here like angles and stuff like that are kind of throwing you off. And it's not really meant to trick you. It's just basically so you understand that the only thing that's being done is gravity is pulling that ball to the ground. Now, does it have to cover a path? Yes. Okay, but I just want to know what is the work being done by gravity. So I only care about vertical in this case. So remember, work equals mass times gravity times distance. So I already told you my mass. So mass is right here, 4 kilograms. Gravity is still 9.8. Now, it does not matter whatever this distance is right here. Okay, all I care about is the vertical distance because gravity is only vertical. Gravity has nothing to do with horizontal. Okay, so my distance is just 10 meters. Okay, so this problem looks super intricate because you have all these angles and stuff, but honestly, it doesn't even matter. Okay, all you care about is mass times gravity times vertical distance. That's it. So multiply those out, and you get 392 joules. Okay, so that'll end this video. The next video will go over kinetic energy on page 14.